NASA says it's Voyager 1, Pro Muamua, which is an object that we detected in space that you believe could possibly have been extraterrestrial in origin, meaning from some sort of civilization. In 2013, Voyager 1 achieved a historic milestone by becoming the first human spacecraft to enter interstellar space, completing the feat 36 years after leaving Earth. The current observatory is 14.5 billion miles from Earth. As a result, messages take approximately 2 days, or 20 hours and 33 minutes, to be sent and received. NASA experts did not expect Voyager 1 to continue space exploration for about 6 months, but this vehicle did it once again, currently found 500 unknown objects in space. Now, world-famous podcaster Joe Rogan has joined the discussion to share the incredible results of this extraordinary discovery. What is this mysterious object? Are they working on aliens or a malfunctioning plane? Join us as we explore how Voyager 1 detected 500 unknown objects floating in space and discovered Joe Rogan's incredible discovery. Have you ever wondered why, despite the unimaginable vastness of the universe, we do not pursue real evidence of alien civilization? This problem is called the Fermi paradox, and it has been a mystery that has fascinated scientists for centuries. But a recent encounter in the depths has surprised scientists and may shed light on the age-old question of whether aliens exist. Joe Rogan is an expert and podcaster known for discussing aliens and the possibility of civilization, and has previously hosted David Grush and other guest researchers on the possibility of life beyond Earth. Now, new data from Voyager 1 may be the key to answering the question of whether we are truly alone on Earth. Buckle up as Joe Rogan explains why Voyager 1's announcement that it has detected 500 objects traveling through space is a game changer, and how it can impact you no matter where you are in the world. But before we get to the fun part, let's understand how Voyager 1's mission happened. Isn't it surprising to think that our wonderful world, with its endless oceans and towering mountains, is just a small part of the bigger world? Scientists have wondered about this for centuries, but it was not until the 1970s that NASA scientists had the opportunity to understand the scale of our cosmic community. It all started with the unexpected conjunction of the 4 largest planets in the solar system: Jupiter, Saturn, Uranus, and Neptune. In the midst of the celestial dance, a medical student named Gary Flandreau, who worked part-time at NASA's Jet Propulsion Laboratory while studying at Caltech, came across a highly surprising discovery. By carefully calculating and plotting the orbital path of the giant planets, Flandreau discovered a phenomenon in the sky that would revolutionize the way space exploration was done. Flandreau's findings are nothing short of encouraging. In the late 1970s and early 1980s, these 4 planets were tracked in a fascinating arrangement like pearls in a cosmic necklace, with Earth among them. This discovery has created excitement at NASA because it offers an unprecedented opportunity to improve space exploration by using the energy currently available from each planet. A spacecraft can propel itself forward using a force similar to the pull of invisible cosmic strings. Flandreau's predictions suggest that gravitational support from giant planets could reduce the flight time between Earth and Neptune from a dangerous 30 years to just 12 years. But there is a problem. This magnificent harmony occurs only once every 176 years. Recognizing the importance of this once-in-a-lifetime opportunity, NASA embarked on a mission to balance the planet. 2 spacecraft, Voyager 1 and Voyager 2, were built with the same design and mission, launched 15 days apart in the summer of 1977. The twin explorers aimed to uncover the mysteries of the solar system and space economics. Voyager 1 was launched on September 5, 1977, and became a key part of the Voyager program, a testament to humanity's curiosity and quest for knowledge. For nearly 5 years, this incredible rover has continued to travel, bringing valuable data back to Earth via NASA's Deep Space Network. It has become our eyes and ears in the vastness of space, crossing the gap between our current world and the unknown world beyond. While marveling at Voyager 1's incredible journey, it's worth noting that it's only a breath away from Earth. As of August 2023, the observatory is an astonishing 14.5 billion miles from our planet. Carefully designed and built by the brilliant minds of NASA's Jet Propulsion Laboratory and powered by the Titan IE launch vehicle, it began its adventure from Launch Complex 41 at Cape Canaveral Air Force Station. Just when you think you've seen it all, the truth comes out. Now let's take a deeper dive into this amazing expedition of 500 unknown objects floating around in space, and the fascinating explanation Joe Rogan recently gave on the Joe Rogan podcast. How did Voyager 1 arrive from space? Imagine a space explorer venturing into the great unknown and reconquering the power of deep space within a decade. That's Voyager 1 for you. This brave spacecraft is already an incredible 14.5 billion miles from our planet. Try to take a moment to think about this. This is equivalent to the distance traveled in 1 year, approximately 3.6 times the length of the Earth and the Sun. But there's much more to Voyager 1 than speed, length, and distance. It also gave us a big reveal, including the recent discovery of 500 unknown objects hidden in the vast area. This discovery is unlike anything we have seen or analyzed before. It is a treasure trove of cosmic mystery and wonder, and we are about to reveal the details of this revelation. You may wonder how a spacecraft that took off in 1977 is still operating and providing such exciting information. The answer lies in the excellent engineering and vision that went into Voyager 1's design. One of the main secrets of this longevity is the presence of 2 backup computers. Voyager 1 and its twin, Voyager 2, are equipped with 2 computer subsystems, the Flight Data Subsystem and the Attitude and Articulation Control Subsystem. This refresh is an ingenious move that ensures the flexibility of systems and the ability to activate computer components when needed, making them last longer. The computer system on the Voyager spacecraft is configured as a distributed system consisting of 3 dual redundant computers. This intelligent planning ensures that even if one of the systems fails, the others can be managed smoothly, preventing the main goal from failing. To make the most of limited power consumption, Voyager devices rely on wired logic. In other words, computer systems are designed with complex algorithms that work within energy budgets and time constraints. Power management during spacecraft construction is an important factor in maintaining operational integrity. Voyager 1's distance from the Sun poses a major challenge to its ability to harness solar energy. To maximize energy efficiency, manufacturers need to find new ways to optimize and save energy. Such a strategy involves power selection for non-critical processes. Engineers carefully examine components or subsystems that are not critical to the mission. For example, the heaters of some research equipment were disabled. These heaters are designed to ensure that the equipment is kept at a certain temperature for efficient operation, and when turned off, they reduce energy consumption, extending the entire service life of the spacecraft. But do not think that the decision about the strength of the process is not important. It includes a comprehensive analysis of the trade-offs between energy saving and objective research. Engineers work closely with scientists to ensure that the removal of certain procedures does not compromise the quality and usability of scientific data. The goal is to achieve a balance that maximizes energy efficiency while maintaining critical performance. This is very interesting. Voyager's power management system can adapt to changing environments. As the spacecraft moves away from the Sun, solar energy decreases. But don't worry, Voyager 1 will adjust its power consumption accordingly, ensuring there are enough resources to support critical operations and data transfer. It's like a smart energy saver that adapts over the years. Significant technological advances and improvements have been made in power management. Engineers are working hard to improve Voyager's power capture using improvements such as greater power delivery, improved battery charging systems, and world-class electrical and management. Thanks to these effective energy management strategies, Voyager 1 has exceeded all expectations. Almost 6 months after its publication, it still continues to send critical messages. Considering that this spacecraft was first launched only 5 years ago, its longevity is truly surprising. It speaks volumes for the dedication and creativity of the scientists and engineers who worked tirelessly to operate Voyager 1. But let's not forget that the depths of space are full of surprises, so hang in there because the discoveries are coming. Designed to explore the vastness of the solar system and beyond, the Voyager mission is equipped with an impressive array of electronic instruments and systems. The instruments were placed in the fuselage of the spacecraft, which consists of 65,000 individual parts. Although Voyager began its interstellar journey with a variety of functional vehicles, only 4 remained operational on Voyager 1 and 5 on Voyager 2. The low-energy charged particle instrument is a long-term instrument aboard Voyager 1 and Voyager 2. The device has 3 sets of particle sensors that measure the number and speed of low-energy particles hitting it. It never tires of looking at cosmic radiation and talking about the sun, planets, and interstellar space. A companion instrument, the Cosmic Ray Instrument, actively searches for high-energy particles from the sun and other galactic sources. Cosmic radiation instruments now detect material emitted from the vast interstellar space, as well as the protective bubble formed by the sun's influence. These readings turned out to be vital in determining the time when Voyager 1 entered interstellar space. It is worth noting that the device is still working on Voyager 1 and Voyager 2. Featuring 2 long antennas at right angles to each other, the plasma wave subsystem is an important tool for measuring the electromagnetic field of potentially undiscovered exoplanets. Its role evolved as Voyager entered interstellar space. Today, the device provides information about the changes plasma waves undergo as they travel through space. More importantly, it also works on Voyager 1 and Voyager 2. Originally designed to study the magnetic fields of outer planets, the magnetometer now plays an important role in investigating the transition zone between the heliosphere and interstellar space. Scientists use this instrument to explore the magnetic properties of the changing region, where the sun's magnetic field interacts with magnetic material from the galaxy, providing a way to find answers. It is worth noting that the magnetometer is still operating on Voyager 1 and Voyager 2. Another important tool is the plasma probe, which identifies the lowest energy material in the plasma body. It can identify objects moving at a certain speed and determine their starting point within a certain limit. These resources become increasingly important as spacecraft move deeper into space. However, it is worth noting that the current measurement only works on Voyager 2.